My name is Jeffrey Frankel, and in this series of YouTube videos I will show you techniques and tips to reduce the time it takes to deal with questions in paper 1 of the IB chemistry exam at both standard level and higher level. When you read this question, the characteristics of the periodic table must come to your mind, and you must be able to see what it is that is different in each element as you go from the left of the periodic table to the right of the periodic table in the same period of the periodic table. And you must be able to say in the back of your mind, the things that changes are the atomic number, the number of protons in the atom, and also the number of electrons in the atom. So as you read through this, you will see that the only one that seems to fit in that is C, the number of electrons in the atom. And if you go through the others, you'll realize that they don't fit. The number of occupied electron levels, that doesn't make sense. The number of neutrons, definitely not. And the atomic mass, no, certainly does not increase in equal steps. So C is the only one that fits, and you could see that fairly quickly. In paper 1, you do have the periodic table to look at. However, if you've done the exercise I've suggested, which is to look at the periodic table for 5 minutes every day for a week and then do it 2 or 3 months later, you will know that element that contains 19 electrons is potassium. And you will therefore remember that the group in which it occurs is group 1. Okay. If you didn't remember that and you try to work it out, you would remember that the structure of the electrons is 2, 8, 8. That gives 18, and then 1 is the final electron. So again, this is evidence that it's in group 1. That electron in the last column is indicative of group 1. This is another question where if you've done my exercise with the periodic table, this question won't be so difficult. If you haven't done my exercise of looking at the periodic table every day for a week for 5 minutes or so, and then doing it a couple of months later, and then doing it with all the periodic tables that they give you in the data booklet, you will have difficulty with this question in an exam situation. You will have to look at this question line by line, and as you read each line you will look at the periodic table, and you'll waste time going backwards and forwards. However, as soon as you see group 5, you will know that group 5 is something like nitrogen and phosphorus, and nitrogen can form a 3 negative charge ion. And so B will be the obvious answer to you. X has 5 occupied energy levels. No, that's not true. X is a transition element. You will know it's definitely not true because transition elements do not have a group number. If you look at the periodic table, you won't find a group number for a transition element. X has 4 valence electrons. No, it cannot have 4 valence electrons if it's in group 5. If it's to have 4 valence electrons, it must be in group 4. So do the exercise with periodic table every day for a week for 5 minutes. Get used to what is a group, that's the vertical columns, and what is a period, that's the horizontal columns, and get used to seeing that if it's in a group, whatever the number of the group, that determines the number of valence electrons. And also that tells you what the charge on the ion, because if the group is 5, the charge on the ion is 3. If the group is 6, the charge on the ion is 2. If the group is 7, the charge on the ion is 1. All of those are negative. However, if the group is 1, then the charge on the ion is 1. That's a positive charge. If the group is 2, then the charge on the ion is 2, that's a positive charge. If the group is 3, then the charge on the ion is 3, and that's a positive charge. This is another question about the periodic table, where if you have examined it and studied it in the way I've suggested, this will be an easy one. Clearly, magnesium, calcium and strontium do have similar chemical properties because they are in the same group, and that is group 2. The other thing to know, which is not directly in the periodic table, but you should know it, is that the oxides of the metals on the left are always basic, whereas the oxides of the non-metals on the right are not basic. They are acidic: carbon dioxide, sulfur dioxide, phosphorus, pentoxide, etc. Okay, so you know 1 is correct, 3 is not correct, and let's have a look at this. Elements in the same period have the same number of main energy levels. That's true. So 1 and 2 are correct, 1 and 2 only. Answer is A. Interestingly enough, you could have looked at this one and said the oxides are, no, that is wrong, 3 is wrong, so therefore B is wrong, C is wrong, D is wrong, leaving only A. So this is again a question where there are 2 different ways of getting to the same answer. Either you know everything about all 3 of these, or you see the obvious one that is wrong, and then eliminate the wrong answers. You are given the periodic table, which has the atomic masses and the atomic numbers in it. You're not given the periodic table, which has the radii, either the atomic radii or the ionic radii. So you just have to know the answer to this, and the obvious answer is K, because K has the extra electron orbit. There. K is 2881, and none of the others have all 4 electron orbits. That's significant. So, once again, if you know the periodic table well, you'll immediately see that an element in group 2 has 2 electrons. That is clearly correct. That one is correct. And an element in period 3 has 3 electrons and 3 energy levels. That's a confusing statement. It's wrong. The element in group 2 in period 3 has an atomic number of 12. Again, you will recognize this immediately as magnesium. And yes, it is in group 2, and yes, it is in period 3, so you'll know that that is correct. So 1 and 3 are correct. So B is the only one that is correct. An element period 3 has 3 electrons. You could immediately eliminate 2, and that's A is wrong, C is wrong, and D is wrong. So there are also 2 different ways of getting to the correct answer. By knowing everything about all 3, or by realizing 2 is wrong. When I look at this, the thing that jumps out at me is electronegativity, because I know in group 7, we're talking about the halogens, fluorine, chlorine, bromine, and iodine, and I know that fluorine has the highest electronegativity in the whole table, and the highest in the group, and therefore all the others will be below it. So I would go for electronegativity. And then I'd quickly realize, no, melting point does not decrease, atomic radius does not decrease, and ionic radius does not decrease. So that, I believe, is an easy one. Again, the only way you can know it's an easy one is if you've studied the periodic tables given to you in the data booklet. I've mentioned this before. Carry one of them with you, take it out for 5 minutes every day for a week, and just read through it just to get the idea, the basic characteristics of the table. Because in the exam, in paper 1, you do not have all the periodic tables with you, and you're expected to have a general idea of the trends of melting points, electronegativity, atomic radius, ionic radius for group 1, for group 7, and for period 3. So it's best to carry it around with you for a week, looking at it for 5 minutes every day, just to make sure you do know the trends of these in group 1, group 7 and period 3. I see this as amazingly simple question. You have to go for MgF2. If you have difficulty with this one, then I suggest you do a lot of practicing with formulas of all sorts of chemicals: magnesium fluoride, sodium chloride, aluminium oxide, aluminium sulfate, copper sulfate, etc. And just get into the habit of writing them down, practicing them, so that this one comes to you within seconds. This is a question about isotopes, and you are expected to know that isotopes have the same chemical properties. You know that, and they have the same atomic number. Those are two things you must know about isotopes. You also must know that they do not have the same physical properties. The atomic mass of isotopes is different, their density generally is different, and there are various other physical properties in which they differ. So we have 1 and 2 are correct, 1 and 2 only, so you immediately go to A. And the other way of looking at it would be to realize, oh, they do not have the same physical properties, so 3 is wrong, therefore B is out, C is out, and D is out, leaving only A. So again, one of those questions where there are 2 ways of getting to the same answer, but you must know the basic characteristics of isotopes of the elements. They have the same chemical properties, same atomic number, different physical properties. Thank you for watching. If you found this YouTube video helpful, please see my other YouTube videos. Thank you.